Just have a few things to add to Luis's presentation. It's quite common for small bodies to be co-located on the sky with background stars or galaxies in the WISE images. The Wide Field Infrared Survey Explorer Moving Object Processing System actively rejects detections with background stars and galaxies. An example of co-located sources are shown on the left-hand images. The top frame shows a single exposure that indicates a possible small body at the location in the sky, and below it is the co-added frame showing a background star at the same position. The right-hand side shows a detection of a small body that is not co-located on the sky with any background source, as shown in the lower right-hand panel. It's recommended to use WMOPS selected asteroids when you want a vetted list of observations that do not have background source contamination. So, for example, if you are doing photometric studies or light curve analysis studies, or you want to debias a population of small bodies that were observed by the WISE spacecraft. WMOPS reports all the detections of its tracklets to the Minor Planet Center, and the times of and positions of these detections are stored in the Minor Planet Center's complete database for all small bodies detections. The numbered small bodies are kept in a text file, numobs.txt, and the unnumbered asteroids similarly in unnobs.txt. Comets are also obtained in their own database text file. In order to utilize the WMOPS detections to obtain a vetted sample, you have to download these database files from the Minor Planet Center, available through the website. Once you combine the files that you want to search together, you can retrieve the WISE observed detections using the observatory code given to the Wide Field Infrared Survey Explorer spacecraft, C51. For the entries in these text file databases, those are the last 3 digits in the final column. Each entry for a WISE observation has 2 lines. The first line is the line of interest in order to extract further information from the WISE photometric database and detection database. The first line contains the object detection RA index and the time stamp. The second line of each observation contains the spacecraft position along with the time stamp. The spacecraft position is in units of kilometers from the Earth's geocenter. After you extract the first line information, you should convert the results into an IRSA input table for the desired detections to get the fluxes and other information using the multi-object query in the WISE database. The RA index should be converted to decimal degrees, and the timestamp should be converted to modified Julian date. After you've made your IRSA table, you can upload the table using the multi-object search option in the Query Single Exposure Level 1B option. You then do a cone search with a radius of 6.5 arcseconds, which is about 1 PSF width, and add an additional constraint for the difference between the database modified Julian date and your uploaded modified Julian date to be less than 2 seconds in day units. As an additional check, it's recommended that you compare the resulting sources from the output of the database query for the single exposure to the Atlas source list using multi-object searches in the level 3 products. This was the method used for the following papers in order to create debiased population studies from the WMOPS detections. Thank you.